As was stated, this will be a bit different topic in the context of 5G and evolution to 6G. But when I was talking to Professor Sujit, I wanted to highlight through some of the use cases, as well as what is happening in the industry and how the data fusion is evolving. And I don't want you guys to see this presentation as me as a Teradata showing what Teradata can do, but more as a context of how we should be approaching the use cases using data and enabling AI and machine learning with those access to the data provided by the wireless technologies. I want to start by saying that one of the interesting elements is data fusion is not a new topic. It's something which was created years ago, and its definition was basically to say to people, we cannot look at one system, we have to have a way to provide accurate information from multiple systems altogether. Some of you may be familiar with this diagram. This is the definition of the data fusion process. As you can see, even if it was created a long time ago, as you can see based on the quality of the graphic used here, the concept that was started with the DoD was extremely highlighting the future, focusing on we're going to have multiple sources, and then we have to create this domain which allows us to do cleansing of the data, which include elements like how can I do the feature extraction and manipulation. At the time, it was focused mostly on we can call the simplified mathematics, where today the elements like feature extraction and optimization required a lot of deep learning and machine learning computation. But on the end, the vision was very correct that we will have a sources. On the other end, we'll have a human who needs to basically interact with this data. What has changed, especially today, is that the recipient of this process is no longer human. There can be a human for observability perspective, but in a lot of cases, we want machines which are using wireless technology to consume this data and be able to make decisions based on them. And this is why the elements which are providing right features, the elements which are focusing on giving us these capabilities are very important, because those machines, they will make mistake if we code and build those mistakes into the process. So what is happening now? And I'm going to be using the reference of NWDAF architecture, which is a very nicely defined set of functional boxes, which correlates what the run analytics as well as how we can interact with multiple sources. What was really for me a big evolution comparing to 3G is that finally we get to the point where the 5G functions, the edge orchestrators, the network is now defined using the common APIs. So there's a standard API framework which allows us to subscribe to the data and be able to not spend too much time understanding those data, but being able to get to the right resource and being able to pull this information at the given SLA. As you can see, there are different SLAs because there are different expectations. In some cases, when we want to do more complex heuristic modeling, or we want to do the feature generation, variable reduction, we probably are looking for the batch processing, which is pulling gigabytes, terabytes, and petabytes of data so that they can be processed and integrated. There are some cases where we need to react fast and do inferencing of our models, and this is where we need streaming. And this is quite important because we cannot really, sometimes in some cases, especially in the private networks, wait for the system to process the data. We need to have sub-second SLAs. And if you look at the industrial world, a lot of PLCs, which are those small enterprise edge processors, their processing loops are operating in 150 milliseconds, which means that we need to be able to capture the data, make decision, and push it back. And this is what this architecture was highlighting, that they are the repository, which contain pieces like 5G data, customer data, reference data, master data, which is an interesting evolution because we all talk about the network, we talk about the network elements, but there are data elements which needs to be there. Because without those data elements like master data management, reference data management, and the whole 5G provider data, it's very hard to make decisions. So it's very interesting that finally we start to see industry looking at the not from the angle of the network, but also from the angle of the data and quality of the data. On the other end, on the consumer side, what is also very interesting and good is that we have now more sophisticated and unified APIs. So we don't have to sort of, again, have a human interact and decide which process I should take for this action, but we can say the machine should subscribe to this API and it will provide the decision in terms of the data feed at the right SLA. The example of the components, so as I was highlighting more on this of the integration with the databases and analytical platforms, is we're going to get data from the 5G, and those data could be a network data. They also could be, as you will see on some of the use cases, a data, the content of the data, which is leveraging the 5G network, and those data are being to be exposed using the APIs. We then basically can use the elements like the core services, which are sending those data to their platform, so that this platform can help support the architecture, make the decision, and then push back the analytical functions and expose those functions as a form of the API. So you subscribe to them, which also have some weakness, which I'm going to highlight at the end, as where we as the industry needs to push the evolution, not from the network perspective, but if we really want to get serious, how we need to evolve the function element of this. Now, if we want to get a bit more of technical in the components, and let's assume that you would like to implement something, not in the case of maybe some of you being a company which are building the network elements, but if you will consider building the platform, which is supported by your network elements, you can use the open source technology like Kafka for topic management and high SLAs, and that gives you very good scaling. And then you can have, of course, Teradata analytical platform. But as I said in the beginning, I don't want the session to be about the Teradata. So in reality, you could leverage a lot of different analytical platforms. There are some of them which are better, like Teradata. There are some of them which are less efficient, but also give you a lot of capabilities. There is also a number of proprietary functions which are developed by probably your companies, which may require you to even provide analytics on a very specialized hardware or specialized configurations. As you can see, the technology has evolved to the level that now we don't have to think about the processing as a single process execution and have a large scale, big predefined platforms for doing those operations. We can leverage technologies like containers and be able to scale out as much as we need. So as example, if you would be going in the private network especially, there are hours of processing where you need more compute power. There are hours and days where you may not need so much. And it's about the ability to give you this flexibility to create more resources for creating those ingest functions so that you can have and maintain the SLAs. Or if you don't need them, you can scale down and basically allow your system to be more optimized and more cost effective, especially if some of the companies will move from being just the provider of the network devices and become more a provider of the overall end-to-end solutions. Like we saw in the years before, what was presented by Ericsson, Nokia, they all are trying to think how we can enable those use cases and how this can be done. Now, as you can see, and you will see Sujit's session talking more about the smart data fusion also, still a lot of those elements, they assume that we take what we subscribe to and then we push this data out. There's not so much optimization. And the problem is, while we may discuss from the network perspective, this is not a very big size of messages, but if you start looking at the industrial data sets, we may be talking about 40,000 variables, multiple gigabytes of data being as a single message. And this is where we have to start enabling this sort of futuristic capabilities of variable reduction, but in the way that we are not losing the context, so that we can do the variable reduction, train the model on correlating variables, but at the same time, don't focus that it's a single target, because the target may evolve over time, and maybe the variables we reduce will be important for different use cases. So as you can see here, the current use cases are much more focused on pushing the data, standardizing the data, and exposing them for analytical processing, there is not yet a lot of development from industry on how we should be focusing on optimizing those data feeds, how we can make those data feeds being more smaller, but yet more focus on the consumption part of it. And so bring more intelligence into the reduction of those data, because those volumes will grow. And this is what is getting to some degree scary, because we could be storing a lot of data while maybe mathematically we can optimize them and use much smaller data sets while still keeping the same quality of information. So some of the summaries about the 5G and beyond connectivity analytics use cases. So as I was saying, there are elements which for example, we work a lot with the operators, and they are looking on how to optimize the network, how to do the slices of SLAs, the handover analysis, even using the network optimization. So how I can deploy the micro stations, how many of them, where I should put them, do I really cover the whole element? So this is what I call the network related or telecommunication related use cases. And as you can see, it's getting really easy to not just read the core data, but you can now visualize, correlate those triangulated information with the location services, and you can start seeing, do I have a full coverage? Do I need a full coverage? Is my coverage needed because maybe my high value customers which are using the network are not so often in this specific area, therefore maybe I don't need to invest a lot in bringing the higher coverage for this network. So there's a lot of use cases which are now finally enabled by the 5G evolution, and I think this will go further and further with 6G. And the nice part is, because of those APIs, there is less time needed spending of decoding the information which is coming from the network devices. In the past, each of the operators was using their customized algorithms. It was very hard to collaborate as an industry in terms of building those solutions and being able to look in the broader scope of those use cases. So it's an interesting time. But I always say the one side of is optimizing the network. And we can say this is an ongoing task, this will never die. But in reality, once majority of the network is optimized, we don't really need to have so much data flowing. We can really focus on specific variables. I think the big evolution with the 5G and 6G will come for the industrial cases, where we are start thinking how I can not just look at the network, but how can also use the network as a way for me to get faster and more and better access to the data provided by the machines which are connected to this network. And I think that is where a lot of doors are opening. And one of the interesting use case, which is maybe strange for today's forum, is the smart warehouse. In a fun way, when I was talking to a lot of customers, even in car manufacturers, talking about the connectivity, they not much complain about the connected car, the lack of the coverage. They said they are still want to solve the basic problems, how I can optimize my warehouse. And I think this is where the private networks are coming to the play, where you can basically have a set of the 5G microstation deploy as a private network, and you can basically start streaming data from more sources, more beacons, as well as the smaller edge devices distributed across the warehouse. You can also use the network to transfer the video feeds. So you can use the AI and machine learning to identify where is the specific packages located, where the specific boxes located, how they are moving, how the workforce is moving, and how I can optimize the location as well as the speed of getting to the right place. So you can see there's a lot of evolution and ways how we can leverage the access to the data, as well as how we can combine multiple sources of the data, not just the network data, but also the video feeds, the audio feeds, the binary data, the data provided by IoT, industrial IoT machines, and start building those use cases and start providing the analytics. So make the data smart. And while this is all interesting and there is a lot of use cases, which I'm always happy to chat with anybody who wants to contact me, even at this time I couldn't be physically in the place, but you can always reach me and I can show you multiple use cases which are enabled by the network. But I also I wanted to spend a very short period of time is discussed a bit what is needed next, because I think this is a good forum, and thanks to Professor Sujit, I think it's a good time to raise some awareness in the industry, what is needed to happen, how we can involve the wireless communication to not be just a pipe for the data, but become a smart service or smart set of services. So I was saying that one of the key elements, which is today not explored a lot, is a smart data fusion. So how we can basically redact the variables provided by some of the devices as part of the data fusion, but in the way that they are not targeted for single consumer being application or the machine. In a lot of cases in the past, the whole discussion was starting, okay, I want to build, let's say, prediction model or yield optimization for silicon design from the probes. The problem was, based on this use case, we were saying, okay, so I need to do the variable reduction. And once this was done, a lot of people realized that what we've done in reducing variables is basically we reduce the data feed to only support this singular use case. So we need to get to the smartness of maybe the more generalized variable reduction, because not every variable is important, not every signal is worth reporting, but at the same time build this in the way that we can do it per different applications. The second thing, which is starting to happen, but we also need to, as I said, we need to focus on all this, how to basically build more use cases, build more services. And this comes to the second point, is that today, as you could see, industries focus a lot on standardization of API, which is, by the way, the great achievement which happened, especially in the network and wireless space. But what we need to get is to the level of, because we now have a technology which allows us to not just expose the data, but also expose the services, the capabilities. And one of the technology which is used a lot in the industry and is growing very fast is protofiles, which coming proto buffers, which coming from the Google. And it's a way of exposing. So imagine the world where you have a team which expose set of capabilities, and then you don't really know how the end consumer, the company X, is going to consume them, which tools they're going to use, which machines they need to integrate to. You cannot develop all of those integrations. With the protofiles and protobufs, you can basically expose the definition of the service and let the protobuffer generate the integration code for you. And this is quite useful, because if something change or evolve in the source of the data, that will give you this capability to regenerate the integration points without human changing those integration services. So I said, this is a very good evolution. I don't see a lot happening in the space, and I think this is an opportunity we are missing, and we have to start thinking. As I said, this is to make sure that we don't use network as a pipe for the data. We use a network as a service enhancement, as a service exposure of capabilities. And you will see more discussions coming from other speakers, as was highlighted. Data is needed, but we also need to start bringing and standardizing the machine learning, deep learning into the data. We cannot be pulling data for doing machine learning, deep learning. We need to really get to the point where we use the technologies to push the algorithms to the data, and also do more heuristic approach. Look not, as I said, from the single target, but look from the multiple targets and how we can enable more use cases. And with that, I want to thank you for your session. And as I said, you can always email me or contact Sujit, and he will contact me if you would like to have more information. Thank you.
Thank you very much, Artur. We have time for a question or two. I think if you have questions, you should get up to the microphone. Artur, so I had a question. As we go down this path of data fusion, do you think about the validity and accuracy of the data that is being extracted from multiple sources? Maybe because there are bad actors, maybe there are competitive interests. How do you make sure that the data that you're fusing is not propagating errors?
It's a very hard problem, by the way. And to be very honest, this is not a problem which is solved by the industry or anybody in this space. There are still problems. Think of the use case like oil and gas. We are still dependent on the operator and define the start time of a certain function. Therefore, there is a misalignment of the dates. This is why this whole element of data management, which include the data quality, the correlation of time periods in the data sets, it's more important to be part of the data fusion. We need to bring this data quality processes, which, by the way, they will not be perfect, and they will need time, a lot of model training to get better and better over time. But this needs to be part of the data fusion, not part of the post-processing. Because as you said, the quality of the data will derive the quality of the mathematics. As somebody says, machine learning will find a correlation even if there is no correlation. And that's this important thing which means to push into the data fusion is how we can make sure we align the proper lead times, how we can enhance data as much as we can using machine learning, how we can provide the missing periods in the time series data sets. And as I said, there is no perfect solution for that today, but that's something which we have to have in mind because we sometimes forget about this. And then we learn that the machine learning, the deep learning we build is not accurate because the data is wrong.
Thank you very much. Well said. So I think let's thank Artur again.